Hi everyone, this is Vivekanandan. Welcome to my Vivek A to Z Chemistry YouTube channel. In this video, we are going to see the valence shell electron pair repulsion theory. That is simply we can say that VSEPR theory. By using this VSEPR theories, we can find out the different types of hybridization, geometry, numbers of lone pairs, numbers of bond pairs, shapes of the molecules. And we are already discussed the different types of hybridization, that is Sp, Sp2, Sp3, Sp3 D and Sp3 D2, Sp3 D3. We have the tricks to find out these hybridizations. I have already uploaded 2 videos related to this hybridization concepts. Those who have not seen, you can see the links in the description box. After seeing the hybridization tricks, you can clearly understand the tricks of valence shell electron pair repulsion theory. Now we are just going to focus the last 4, that is geometry, numbers of lone pairs, numbers of bond pairs, shapes of molecule. Let's discuss one by one. And here the first one is Sp hybridization. The molecules of Sp hybridizations are BeF2, mercury chloride, zinc chloride, and here the central atoms has 2 atoms, that is fluorine. Okay, these are all linear shapes, and here the geometry is linear. And here we have to go to the next one, that is lone pair. How to find out the lone pair? First we have to know the valence electrons, that is 2, 2, because the atomic number is 4. Okay, the valence electron is 2. Just put 2 dots. Okay, and here just look at this molecule, and here there are 2 fluorine atoms. Okay, just to fill 2 fluorine atoms. Now look at that, there is no extra electrons, so no lone pair. Okay, and here how many bond pairs are there? And here 2 bond pairs are there, 2 bond pairs, and shape of the molecule is also linear. When the lone pair is 0, then we have to say that the geometry and shapes of the molecules are similar. Okay, let's move to the next one. So here Sp2 hybridization, and the first one is a trigonal planar. Examples of a trigonal planar, that is BF3, BCl3, CO3 2 minus, NO3 minus. These are all comes under this Sp2 hybridization trigonal planar. And here, so first Sp2 let's write. Move to the next one, geometry. And here the geometry we know that is a trigonal planar. Okay, and lone pair. Lone pair, so we have to find out the lone pair. I already told that the tricks. So boron atomic number is 5. Okay, so we have to write the electronic configuration 2, 3. The outermost electron is 3. Just to put 3 dots. And here the 3 fluorine atoms are there, just to fill it here. Okay, and there is no extra electrons, so no lone pair, no lone pair. Okay, and here the bond pairs are 3 bond pair, and shape of the molecules also trigonal planar. And move to the next one. Here V shapes are there, and here some of the molecules, that is tin dichloride and lead dichloride. So tin and lead, it comes under the carbon family. So just that is like a carbon, we know that atomic number is 6, so we have to write 2, 4. So the outermost electron is 4. Keep 4 dots. Okay, and fill that chlorine, because tin and lead comes under the carbon family, so the outermost electrons are 4. So here lone pairs are there, 2 electrons are there, so that is 1 lone pair. So one lone pair and 0 bond pair. Sorry, there are 2 bond pairs are there. Okay, so easily we can find out the lone pairs and bond pairs. And here, if one lone pair is present, then the shape of the molecule is V-shaped. So the geometry is trigonal planar, shape is V-shaped, and one lone pair, 2 bond pairs. So we can see the difference. Okay, so by using the same technique we can go for the next one. And here next one is Sp3 hybridization. So just write Sp3 hybridization, and here we know that examples, just consider methane, that is a CH4, and tin tetrachloride, ClO4. These are the examples that comes under tetrahedral structure. And here geometry is tetrahedral, right? Let's write TD. And lone pair, whether it is present in the carbon or not, just put the 4 dots, because the carbon atomic number is 6 and the electronic configuration is 2, 4. So the outermost electron is 4. So we can occupy this each electrons by hydrogen. Okay, so there is no lone pair. So no lone pair means that is 0 lone pair. Okay, no lone pair. And here bond pairs, how many bond pairs are there? 4 bond pairs. Okay, shapes of the molecule. If the geometry shapes are equal, means that we have to write that there is no lone pair. Okay, so already I told you. So geometry and the shapes are similar if there is no lone pair means. So let's move to the next one. And here NH3, PH3 and SO4 2 minus, and last one is PO4 3 minus. These are the examples that comes under pyramidal structures. And here geometry we know that is a tetrahedral. Let's move to the next one, that is a lone pair. And here we know that nitrogen, right? Nitrogen, the atomic number is 7. So electronic configuration is 2, 5. Okay, so 5 dots we have to keep it, 1, 2, 3, 4 and 5. So here each one we have to occupy that is a hydrogen. So one lone pair are there. Okay, so easily we can find out that is one lone pair and 3 bond pair, and the shape is pyramidal shape. Geometry is tetrahedral geometry. Okay, so easily we can find out. Last one, that is a V-shaped molecule, so that is a H2O, and one more is there, H2S. Okay, so let's find out the lone pairs, bond pairs and shapes of the molecule. We already said that is a V shape. And here oxygen atomic number is 6. Okay, oxygen atomic number is 8, 2, 6, the electronic configuration. The outermost electrons is 6. Just keep 6 dots. Okay, and here hydrogens are there. So hydrogen, this one is also hydrogen. So 2 lone pairs are there. Okay, so 2 lone pair and 2 bond pair. Okay, so 2 lone pairs and 2 bond pair. So here the geometry is a tetrahedral and the shapes is V-shaped. Okay, let's do the one more example. So that is a sulfur. Atomic numbers is the same, that is 15, and the electronic configuration is 2, 8, 6. Atomic number is 16. Okay, so here we have to keep the same 6 electrons. Okay, and each electron is occupied by a hydrogen, and this one also hydrogen. So 2 lone pairs are there. So same tricks only. Let's move to the next one. And here you can see that is Sp3 D hybridization. And here the 4 categories are there. the first one, different types of hybridization. So we have to write that is Sp3D. Okay, in geometry that is trigonal bipyramidal. Okay, TBP, that is trigonal bipyramidal. Lone pair we have to find out. So here Sp3 D hybridization. So first one PF5, PCl5 and SbCl5. These are all comes under trigonal bipyramidal structure. So let's have a look of lone pairs. So that is phosphorus, we know that atomic number is 15. Okay, so 2, 8, 5. So here the outermost electrons are 5. So just to keep the 5 dots. And fluorine, how many fluorine? 5. So we'll just fill the 5 fluorine. Okay. So there is no lone pair. No lone pair. No lone pair. So no lone pair means geometry and the shapes are both are same. Okay, and here 5 bond pairs are there. 5 bond pair. Okay, for this one is a 5 bond pair. Let's move to the next one. And here seesaw structure. So seesaw structures example SF4 and TeCl4. So here sulfur, we know that atomic number is 16. Okay, 2, 8, 6. So keep 6 dots. Okay, 6 dots. Each one just to fill fluorine. Okay, and here one lone pair is there. Okay, so seesaw means, and here bond pair and one lone pair. Okay, one lone pair. So if one lone pair is there means the shape is a seesaw shape. Okay, so let's move to the next one, that is T-shaped. Examples, that is chlorine trifluoride and bromine trifluoride. These are the examples of comes under the T shape. And here chlorine, we know that atomic number is 17. So outermost electron will be 7. So just to keep 7 dots. Okay, so each one just to fill fluorine. Okay, now tell me how many dots are there? 4 dots, 2 lone pairs. So it means that is 3 bond pair and 2 lone pair. Okay, so geometry is the same, trigonal bipyramidal only for all, but shape of the molecule is T shape. Okay, so 3 bond pairs and 2 lone pairs are there. So the last one here, that is xenon difluoride. We know that the electronic configuration of a xenon. So the outermost electrons will be 8. Okay, for noble gases. So just keep 8 dots and fill 1 fluorine. Okay, so here you can see that 1 lone pair, 2 lone pair, 3 lone pair. Okay, so 2 bond pair and 3 lone pair. Okay, so the geometry is a trigonal bipyramidal due to the presence of 3 lone pair, and we have to say that a linear shape. Okay, so let's move to the next one, that is Sp3 D3 Hybridization. And here examples, that is SF6 and TeF2, F6. Okay, so we know that the sulfur is a 16 atomic number. So 2, 8, 6 electronic configuration. So outermost electrons is 6. So keep 6 dots. Okay, and fill that each one is fluorine. So there is no lone pair. So if there is no lone pair means that is geometry and the shapes both are same. What is the geometry for SF6? Octahedral, and shapes also octahedral. And lone pair, 0 lone pair. Okay, 0 lone pair. And bond pair, 6 bond pair. Okay, so same trick we can go for the next one. So that is square pyramidal, and here IF5 and BRF5. BrFi, IFi. Okay, so we already know that is for bromine and iodine, the outermost electron is 7. Okay, so each one occupied by fluorine, each electron. Okay, so here 5, so one lone pair is present, so one lone pair and 5 bond pair. Let's move to the last one, that is xenon tetrafluoride. We know that electronic configurations, the last one, it will be said as 8. Okay, so just to keep 8 electrons. Okay, and here just each electrons occupied by fluorine, so total 4 fluorine are there. So here we can see that the 2 lone pairs are there, so 4 bond pair and 2 lone pair. Okay, 2 lone pair. So the geometry is octahedral, and due to the presence of 2 lone pair, the shape of the molecule is square planar. Let's move to the next one, that is the last one, Sp3 D3 Hybridization. And here the last one is a Pentagonal Bipyramidal, and here this one is comes under IF7. So we know that the outermost electron is 7. Okay, so we have to keep 7 dots. Okay, so then each electron is occupied by 7 fluorine. Okay, so 7 fluorine we can put. Okay, so there is no lone pair, so no lone pair. If there is no lone pair, means the geometry is pentagonal bipyramidal shape, and the shape of the molecule is also pentagonal bipyramidal. There is no lone pair. Okay, so here 7 bond pairs are there, bond pair. So no lone pairs, 7 bond pairs are there. Okay, I hope you all understand this valence shell electron pair repulsion theory. Please subscribe my channel to get more videos related to your competitive exams. Thanks for watching.